All right, here is the key to the review. All righty. So Steve and his friend are playing together on a seesaw as shown in the figure above. At time t equals 0 seconds, the distance between the top of Steve's head and the ground is 24 inches. At its highest point, his head is 60 inches above the ground. Okay, so here is, that would be what, 24? And then we'll say this is like Steve 2.0. Well, that's terrible. That's 60, okay? Lowest and highest. Steve's head is 60 inches above the ground. Steve goes, this is what some people had trouble figuring out, all the way up and back down on the seesaw every 3 seconds. So if he starts down here and he's at 0.24, then he's going to go up and come back down. So in 3 seconds, he's going to be back at 24. So in between the two minimums, there would be a maximum of 60 for the y value, okay? And it would be halfway in between, so it's also halfway between 0 and 3. On the key that I had printed, I used fractions, so I'm going to use decimals here just to do it differently because the fractions boggled some of your minds. But I will tell you that you will definitely have a question like this on the exam, whether it'll come out to nice, pretty whole numbers, or it will be fractions, or it will be decimals. Have no idea. It could be anything. But halfway between 0 and 3 is going to be 1.5. Okay. Then it says, as the two friends play on the seesaw, the distance between the top of Steve's head and the ground periodically increases and decreases. That's the whole point of what we're doing. So the periodic function d models the distance in inches between the top of Steve's head and the ground as a function of time in t seconds. So this is t d of t, basically, is what's happening. Okay, so the graph of d sort of disappeared, and its dashed midline for 2 full cycles is shown, and we have these labeled. So we need to figure out what these are. So I know, whoa, I don't know what's happening there. Okay, let's get rid of all of that. All right. We know that the lowest points are 24, highest points are 60. So this would be, well, this would be 24. These would be 60, right? So if I worry just about y, halfway between 24 and 60, so that's 84. If I add them, divide by 2, these y values would be 42, okay? So sometimes, depending on the situation, it's easier to just deal with all the y values than you can deal with all the rest of them. So we know we have these two x values of 0 and 3 for 24. I know that this cannot be 0 because if I go backwards and get these, I can't have a negative time. So I would have to come back a little bit and get a point right here, and this point could be 0.24. It goes all the way up and comes back down. This would be 3.24. So then halfway between those two, that's where our 1.5 comes in. Then to find this x value, it's halfway in between these. So if I do 1.5 plus 3, that's 4.5. And if you think in terms of money, 450, if I break that in half, that's 225. Again, the fraction is totally fine as well. We really should be at a point where it's a little nicer to deal with fractions, but we'll see. So if the distance from minimum to minimum is 3, we agree that that's 3, right? Then the distance from maximum to maximum is also 3. So what is 3 plus 1.5? 4.5, right? Then 3 plus 4.5 is 7.5. And this is why I don't want y'all dealing with decimals, because some of y'all ain't going to get that right. But half of 7.50, well, half of 7 would be $3.50. And then half of the 50 cents would be 25. So this would be 3.75, like so. Okay, so again, fractions or decimals, but there are points. Okay, everybody good? All righty. So then it says to refer to the graph of D in part A, the t coordinate for F, so here we're talking about F, is T1, G is T2. So we're looking at this part of the graph. And it says, on the interval from T1 to T2, which of the following is true about D? Is it asking me anything about rate of change? No. So do I need my fun chart right now? No. And my fun chart might confuse me. D, the function itself, right here, is this function positive or negative? Positive. Is this function in particular ever negative? No. If it was negative, he'd be going like underground, right? Okay, so we're looking at our y values. It's always positive, so can't be those two. And then is this part increasing or decreasing? Decreasing. So my answer is B. All right, we good on that? Okay. Then it says to describe how the rate of change of D is changing over this same interval. Now we're talking rate of change, so now I want my fun chart. And there has been an update to the wording that they're actually going to use on this question, because like I said, this problem situation changes, but it's gonna, I mean, this question might change a little bit, and the intervals will change where they are, but you're still asked the same questions. It'll not only say describe how the rate of change is changing, but it will also tell you to mention the concavity, which kind of gives things away, right? So I know that part of the function, we already said that the function is positive and decreasing, so the function is decreasing, but it's also, is it concave up or down? Down, right? On the green part, that's concave down. So I know that the rate of change is decreasing and negative. It's asking me how it's changing, so this is the part I want. Yes, the rate of change is negative, but we don't need to talk about that, okay? We're talking about the part that is related to the concavity. So then we can say that the rate of change of D is, and the rate of change we know from here is decreasing. Is the rate of change, of D. Is the rate of change always decreasing? No, so we have to mention the interval. Is decreasing on T1 to T2, okay? And we know that because D is concave down on T1 to T2. Okay. Questions about that? So we have these parts said here. Yes? Any questions about what? And this does not say dis, that says D is. And you have to make sure that you mention D, that you mention the concavity, increasing or decreasing, and the intervals. Okay, we all get on that? All right, so this is the one I told you to omit because it talks about cosine and then it has all sine answers. So as long as we can understand what's happening, first of all, make sure you actually read the questions, because it does say we have an angle of theta in standard position and that the terminal ray of the angle intersects at point P. So this is my angle right here, which means if this point is 3, 4, this is 3, -4, right? And so the cosine would be 3 over 5 because my radius is 5. And, or you could put x over 5, kind of the way it was asked. But remember that we're talking displacement. X is your horizontal displacement. Y is your vertical displacement. The radius is a distance. That's why it's always positive. Okay, so as long as we would understand how to answer it, we're not like justify that thing with an answer because it's weird anyway. Okay, the figure shows a circle with a radius of 13. If it didn't tell me here, it tells me here, so I need to pay attention to that. Centered at the origin, terminal ray of the angle intersects at point P. So once again, bless you, we are here. So if that is 512, this is 5, -12. Right? So sine, if this is not a unit circle, so sine is not just y, sine is going to be y over r, and my y value is a -12 over 13. Cosine is x over r, so that would be 5 over 13. Tangent is y over x, so that's negative 12 over 5. Okay, everybody good with that? Questions? All right. Then we have let theta be an angle in standard position whose terminal ray coincides with this line in quadrant 3. So here's my circle, my little quadrants. Okay, it's okay if it doesn't look perfect. Here's my line, y equals 5x, would look like that. And we're saying the terminal ray intersects there. So this is my angle coming to here. And then it tells me to find the following values. Well, one of the values I know right away, because I have to make this connection, is that tangent is the slope. It is the slope of the line that intersects right there. So tangent is 5. Okay, I have to do 0 work for that. Tangent is the slope of that line. So it's not 5x, it's 5. Then I have this right here. I've got this little triangle here, and there's theta, right? So if I redraw it a little bit bigger, this is theta. I know that tangent is y over x, so this would be 5 over 1. But since this is in the third quadrant here, both of those are negative. Okay. To find r, I need to do Pythagorean theorem. So negative 1 squared plus negative 5 squared equals r squared. So that's going to be 1 plus 25 equals r squared. So r squared equals 26. R is the square root of 26, and it's the positive square root of 26 because r is a distance, so we don't care about the negative part. Okay? Everybody good with that? So then we find our sine. Sine is the y value, which is negative 5, over the radius, which is the square root of 26. And then when we rationalize, we get negative 5 times the square root of 26 over 26. Cosine is your x value, negative 1, over the square root of 26, which gives you negative square root of 26 over 26. Okay. What questions we got? All right. So this next part, and actually some of these things are going to seem almost too easy, but that's because we started the unit circle before we really got into this, so you know it a little bit better than if I had just started when we did unit 3. But it says the figure at the right shows a circle centered at the origin with beta being pi 6. So this angle is pi 6. So then it says find the measures of the angles in standard position whose terminal rays intersect at the other one. So basically my other pi 6 angles. But because we're so good at this, we know that when we get here at pi, this is 6 pi 6. So when I back up 1, I get 5 pi 6. When I go forward 1, I get 7 pi 6. And then this would be 12 pi 6. So I back up 1, and this is 11 pi 6. Okay, not the ordered pairs, but I just put them there because it was easier. Any questions about that? We all good on that one? All right. So then we have, says let alpha be an angle in standard position with a terminal ray intersecting a circle centered at the origin at point P. If P is in quadrant 2, which of the following could be alpha? So again, something I think we should be pretty good at by now is figuring out the quadrants. So let's just, pi 6 is in which quadrant? The first. 3 pi 4s is in which one? The second, right? 7 pi 6 is in which one? Third. And this one is in which one? Fourth. Okay. So this is my answer here. Okay. Everybody good with that? I think that's something we're hopefully pretty good at this point. So 4 pi thirds, what quadrant are we in? Third. If the numerator is 1 more than the denominator, right? 5 pi 6 is in which quadrant? Second. This one is in the fourth. And this one is, it's a quadrantal, right? And that ordered pair would be 0, -1. We are looking for quadrant 4 here. So my answer is C. Okay, we okay with those? All righty. So then, 5 pi/12. Well, is pi/12 an angle that you were familiar with? No, but let's say it didn't reduce. Let's say I gave you 13 pi/12. What quadrant would 13 pi/12 be in? Third, because this would be 12 pi/12, right? You move forward one, you're going to be at 13 pi/12, right? So we can still kind of figure those out. They're not, it's oops, oh goodness, did the wrong thing there. It's not the same as like, not all the exact same rules, but we can figure it out. But we can reduce this one. This reduces, if we do it right, which I saw so many different people do it wrong in different ways. I know you know how to, let's see, I'm about to sneeze on this. Okay. I can divide them both by 3, so that gives me 5 pi/4, right? What quadrant is 5 pi/4 in? Third. What quadrant is pi in? It's a quadrantal, and that ordered pair would be, oops, doing the wrong one, -1, 0, right? What quadrant is 5 pi/6 in? Second. And 7 pi/4, fourth. Okay, and here we are looking for third, so my answer is A. Okay, we all good with those? Awesome. All right, so then we're supposed to sketch these in standard position. So it helps to know your reference angles and what they are in degrees. So pi/4, what is pi/4 in degrees? 45. That way you know what to aim at right here, right? And then this right here would just be your pi/4. Oh, need a little arrow there going that way. 2 pi, well, that's quadrantal, right? That's one whole rotation. That's just what that one looks like. I start here. 7 pi/4 is in which quadrant? Fourth. And pi/4 is 45, so I should be halfway through the fourth quadrant. And it should look like this. And again, something we've been doing for a while, so hopefully we can figure those out. We good? All right. 2 pi/3. So what is pi/3? Well, first of all, what quadrant is 2 pi/3 in? Second. And what is pi/3 in degrees? 60. So if I get to 3 pi/3 here and I'm going to back up one, that means I'm going to back up 60. So I need to be about a third of the way there. Looks something like this. And that would be 2 pi/3. I don't expect you to get out a protractor and make it exact, but I expect you to kind of aim for what would make sense. 3 pi/2. What quadrant is that in? It's a quadrantal. Is it north, south, east, or west? South. It's kind of a good way to say it, right? It's down here. And then this is 3 pi/2. We can practice our directions too. All right, 7 pi/6. What quadrant are we in? Third, right? What is pi/6 in degrees? 30. So if I'm here and I'm supposed to go forward 30, I'd go forward about a third. Should look something like that. There's your 7 pi/6. Okay. Questions about those?
Yeah, I'm good.
Okay. All right, these are values that we should know pretty quickly, I hope. We first think about sine is, so 3 pi/4 is in the second quadrant. And the second quadrant is sine positive or negative? Positive. So then the sine of pi/4 is square root of 2 over 2. Okay, so think about your quadrant, your sine, and then your value. And I'm going to go down even though 2 is over there. So cosine, here's 5 pi/4. What quadrant is that in? Third. Okay, and the third quadrant is sine positive or negative? Negative, yes. And then this is cosine. And then this is negative square root of 2 over 2. And don't forget that this, what is my little saying as I go around here? Students take suffer. There's no suffer in there. All students take calculus. Okay, so 4 pi/3. What quadrant are we in? Third. Sine is what? Negative. And then what is the sign of pi thirds? Square root of 3 over 2. 11 pi 6, what quadrant are we in? Fourth. So is this going to be positive or negative? Negative. The sign of pi 6 is 1/2. Okay. Pi, what quadrant are we in? It's a quadrantal, so this is -1, 0. What's the sign? 0. All right, 5 pi 6, what quadrant are we in? Second. Okay, second quadrant, because I'd have to back up 1. Is cosine positive or negative? Negative. What is the cosine of pi 6? Square root of 3 over 2. Very good. All right, 2 pi thirds, what quadrant are we in? Second. So is this positive or negative? Negative. Cosine of pi thirds is 1/2. Very good. All right, pi halves, what quadrant? Quadrantal, and that is 0, 1. So what's the cosine? 0. Cosine of 0, what quadrant? Quadrantal, and that is 1, 0. So the cosine is 1. 7 pi fourths, what quadrant are we in? Fourth. Cosine is what? Positive. And what's the cosine of pi fourths? Very good. Okie dokie. 3 pi halves, what quadrant? Quadrantal, and that one's going to be 0, -1. So what is the sign? -1. Good. What quadrant is pi 6 in? First. Everything's positive. What's the cosine of pi 6? Square root of 3 over 2. All right, pi thirds also in the first. So what's the sign of pi thirds? Square root of 3 over 2. All right, 7 pi 6. What quadrant are we in? Third. Sign is what? Negative. Sign of pi 6 is 1/2. All right, 5 pi thirds. What quadrant are we in? Fourth. So sign is what? Negative. Sign of pi thirds is square root of 3 over 2. Okay. Now, if you need more help on that stuff, don't forget you have quizzes that if you've already done them like you should, you can still go back and do them again, just to kind of help you practice with that stuff. I think that's a good way to do it. All right. Now, we're given an angle of theta in standard position and radius r centered at the origin. Find the coordinates of the point where we have this angle and this radius. And I don't necessarily need to draw a picture here. I mean, I could, but I know in a unit circle, it's cosine sine. This is not a unit circle. So if it's not a unit circle, it's r cosine theta, r sine theta. Okay, you just put the little radius in front of it. It's how it works on a unit circle too. It's just that r is 1. I know my r is 4. So this is going to be 4 times the cosine of -5 pi 6 and 4 times the sine of -5 pi 6. All right, so even though I don't necessarily need to draw a picture of the whole thing, I think maybe a little something might help me, because if I think about, I need to figure out where -5 pi 6 is. If I start here, what quadrant is -5 pi 6 in? Second, because this would be my 5, this would be 6 pi 6, and I back up 1. So because I have to go this way since it's negative, right? So this would be -6 pi 6, and I got to back up. I'm actually in quadrant 3. Okay. So then all I need to know is in quadrant 3, is cosine positive or negative? Negative. So this is going to be 4 times a negative. And then what is the cosine of pi 6? Square root of 3 over 2. Okay. And then this is going to be 4 times, I'm still in the third quadrant, and the third quadrant sign is what? Negative. And what is the sign of pi 6? 1/2. So then this will give me -2 square roots of 3 and -2. Okay, we got on all that? All right, next one. The sinusoidal function f of theta is shown in the figure above. Find the period, frequency, amplitude, and midline of the graph. Okay, so I think the midline, for me anyway, that is usually my go-to thing at first. So I think if I put that there, So like that looks like it's in the middle, right? Midline, keyword here is line. So that is at y equals 10. Along with the midline, the next probably easiest thing is to figure out the amplitude. And if you look at it in both directions, you should get the same number on both sides, right? And if you don't, then your midline's wrong. But my amplitude is 20. Okay. How are period and frequency related to each other? They're reciprocals, right? Period's probably the easier of that to find because that makes sense to us. So if I start here, I can look at this as sine, and I can go from here to here. That is one cycle. Since I started at 0, I see that my period is pi, which means my frequency is 1 over pi. Okay, everybody good with that? Yes, awesome. All right, so here's one we need to draw for ourselves. And we don't have to get crazy with it. We don't have to draw the entire thing, but we should draw something to make it make sense. So I have h of theta as a maximum point at 3:15. The first minimum after reaching the maximum is at 8:3. Okay, so here's my little graph here. I'm going to be at 3 and 15, and I'm going to be at 8 and 3. Okay, so I'm going to have a point at 3:15 and a point, oh, I didn't make that 8, at 8:3. Okay, and that is a maximum and a minimum. So the next thing I think I want to figure out is my midline. What is halfway between 3 and 15? I can do it 2 different ways. I can add 3 and 15, get 18, divide by 2, midline's at 9. Or I can subtract them and get 12, which means the distance from the midline is 6. So like whichever way makes more sense to you. But this right here would be at 9. And then you can see you'd have 6 here and 6 here. So you know you're good and you're in the middle. All right. So that means my midline is at y equals 9. My amplitude is what? 6. Okay. So then if I sketch this in, which I don't necessarily have to, halfway between 3 and 8, I have a point on the midline, but that's really kind of irrelevant, but just so you know that that's there. So if I'm going to start here, come down, I'd have to come back up. So from here to here is half the period, right? I don't have to draw the whole thing out, but if I go from maximum to minimum, I'm then going to go from minimum to maximum. So that's halfway, that's 5. So then what's the whole period? 10. And then my frequency is 1 over 10. Okay. What questions you got? So you don't have to draw even the whole cycle if you can make it. I think I did the first couple just so you can make sense of it, but you don't have to. And we don't know if we're talking about sine or cosine, but it doesn't matter. So even up here, just to make this clear, if I had started here and said, I'm going to do this cycle till I get to here, that still gives me the same period because I'm going from pi fourths to 5 pi fourths. I just have to subtract that stuff. I would still get pi. It's just not as pretty as if you start at 0. So, or not as easy, I guess. We all good so far? Okay. All right. So the sinusoidal function, here's another, it's another one of the same kind of thing here, has a minimum point. So let's draw this out. And I am going negative here. Okay, so at pi halves and -1 and pi, I'm up here at 7. Okay, so I have a point here that's going right on top of my pi, but that's okay, and a point here. So then if I draw in my midline, it doesn't even have to be accurate. I just have something that I can label there. What's halfway between 7 and -1? Or maybe this is an easier way to think about it. If I'm going from -1 to 7, that is 8 spaces, right? I'm going to walk 8 spaces up. Half of that is 4. So that means I got to go 4 spaces from -1 to the line and 4 more from the line to 7. So where does the line have to be? 3, right? Because then this is a distance of 4 and this is a distance of 4. Okay. Okay, everybody okay with y it's at 3? All right, so that means my midline is at y equals 3, and my amplitude is what? 4, because those are those 4 spaces there. So then I'm going from minimum to maximum, which means that is half of the period, right? Because then I would come back down. So the distance from pi halves to pi is how much? Pi halves. So this is a distance of pi halves. That's half of it. So the whole period is what? Pi, which means the frequency would be 1 over pi. Very good. Any questions about that? We're good? Beautiful. Okie dokie. I know I'm not going to get through the whole thing with y'all, but I'll get through some of it at least, and then I'll finish the rest later. All right, which of the following best describes the behavior of f over the interval from 0 to pi halves? So I'm going from 0 to pi halves on this first one. All right, so here is what I'm looking at. And it talks about, so is the function f, is f increasing or decreasing? Increasing. So I can eliminate those two. Then it talks about the rate, which means I need the fund charge. Okay. So if I want to know if the rate is increasing or decreasing, I'm looking at the concavity. Right there, is it concave up or down? Down. So that means the rate is doing what? Decreasing. Very good. Okay, we good with that? All right. So then we're looking at from pi halves to 3 pi halves, this right here. That is this part. So it says f is positive and increasing, or actually, let's just look at, is f positive or negative? The function is positive because my y values are above 0. So the function is positive. When you're, here it's 0, but see how it doesn't include it? So we're good. So the function itself is positive. So I'm going to eliminate those two. Is the function, because we don't need our fund chart here, is the function increasing or decreasing? Decreasing. Decreasing. So the answer is B. Now, could I, it doesn't say this here, but could I say one statement about the rate of change increasing or decreasing on that interval? Is from, on my pink part here, is the rate of change always increasing or always decreasing, or neither? Or neither answer makes sense, I guess is what I'm saying. Neither answer makes sense, because if the rate of change is decreasing, then the rate of change is increasing because we changed concavity, right? That's why I didn't ask about rate of change on that one. All right, then the next one, we're going from pi to 3 pi halves. So that is here, this part here. It talks about the rate of change both times. So I need to look at the function. Is the function on my purple part concave up or down? Up. And is the function increasing or decreasing? Decreasing, which means the rate is increasing and negative. So negative and increasing, which is C. Okay. What questions y'all got? We good on those? Okay. Let's see if I can get another one in before the announcements come on. All right. So I'm trying to find A, B, and D. And I know that A is the amplitude. I still think D is probably the easiest thing to find first. Let's just do this. We need A, B, and D. All right. So going from -1 to 3, so my midline should be here, right? So that means D is 1. What is A? Amplitude. And what is it here specifically? 2. Okay, because that's this distance right here. Then I need B. B is related to the period. Whether this says sine or cosine, it doesn't necessarily matter here. But now that we look at this, do we have a shift left or right? We're not shifting left or right, are we? So that A, the amplitude is 2, but is A 2? You see how I'm starting down here? A would have to be a -2. So the amplitude, the distance is 2, but because we're not shifting left or right and we're starting down there, it has reflected. That's why it's a -2. You with me on that? So if I start at 0 and I go to here, that's the period. So the period is 4 pi. To find b, I take 2 pi and divide it by the period. So what is b going to be? 1/2. Okay. What questions we got about that? We good? We'll probably do the next one too. All right. So now we're trying to match these up, right? Okay, so I see the midline is the same on all of them. Then I either have sine or cosine. I'll get to that in just a minute. But I can tell that the amplitude is definitely what? 4. So I can eliminate b. Positive or negative, not sure yet because we got some shifts going on in here. So I'm going to start, and remember that sine looks like this, cosine starts like this, right? So I'm going to start with this one. If it is sine, it starts on the midline right here. I am not shifting left or right. And then I have a sine function. I like all of that. I got to check this. The period is what? Period is 8. If I have to take 2 pi and divide it by the period to get b, before I even do anything, am I going to get 8? No, so that's not it. All right, so then I've got 4 cosine, and I do shift, so let's just hang on a second here. Cosine would start up here. I would shift to the right 2, end up right here. And then I would have a positive cosine, so things are looking okay so far, but I need to check that. All right, so if I take 2 pi and I divide it by 1/8, that's going to give me 16 pi, right? That is not what that's a no, okay? So then I'll look at this one. That's a negative sign, but sine starts here. I would move to the right 4, and then since it's negative, I would go down first, so that's looking okay. B is pi fourths, so I'm going to take 2 pi, divide it by pi fourths. That becomes 2 pi times 4 over pi. That's where I get the 8 from. That is my answer. Okay, so on those, you kind of have to check them all, but try to minimize what you have to go through as you do it. All right, let's do this last one here. Okay, we've got a sinusoidal function. We want the values. All we want here is the period and the amplitude. So I'm going to start with the midline is right here. So it makes my amplitude 2. Remember, there's a difference between A and amplitude. Amplitude is always going to be positive. So I know it's not B or D. And I need the period. I'm going to start at 0. Doesn't matter if it's sine or cosine. If I go 0 and then I end here, the period is 4 pi. All right, now we have the population of deer in a wooded area can be modeled by D, which is this function here. Based on the model, which of the following is true? Okay, so one thing that makes this look a little bit different, and sometimes that blows your little minds, is it is starting with this number. I could rewrite this as d of t equals negative 1200 times the sine of pi 6 times t minus 2, and then plus 5200. Okay, they just put it in, sometimes it's put in front when that's negative, but it means the exact same thing. Okay, so this says the maximum number of deer is 5,200. All right, so let's just kind of have our little sketch here. This we know is D, and that is the midline. So let's just say that this is my midline. This is 5,200. That is definitely not my maximum. That's the midline. It's literally middle. There'll be something above it and something below it. So I know that that is not my answer. My amplitude is 1200. So if that's at 5,200, then I would have my minimum is at 4,000 and my maximum would be at 6,400. Okay. It does say I do have the minimum number of deer is 4,000. Okay. And then it talks about the maximum and minimum occurring at t equals 0. Well, so I like C, but let's talk about B and D. I have a shift here, and let's see, and these are months. So if I look at, this is 2 right here, and that is sine. Sine starts on the midline, and then this is negative, so it would go down first. And let's see, period. So B is pi 6, so the period would be 2 pi divided by pi 6. That would give me 2 pi times 6 over pi. And that's where you get the 12 months from. So from 2 to 14, that's a distance of 12 there. That would be my period. So halfway in between here, I have to come up and then come back down like that. So there's no way that I'm going to have another minimum or maximum at 0 if I back up some. It took me, so let's see, halfway between 2 and 14. This would be at 8. This would be at 5. So a minimum is happening at 5. A maximum is happening at 11. So if I back up to get a maximum, it would have to be, this is 3 spaces, the maximum would have to be here. So I don't have a minimum or maximum happening at 0. My answer is C. All right. Function K is defined here for constants A, B, C, and D, although there is no C in there. In the XY plane, the points 0, 12, and 2, 2 represent consecutive maximum and minimum values. All right, so again, I would draw a little thing here. I've got 0, and then I'll be at 2, and then I'll have this at 2 and at 12. All right, so I have a point at 0, 12, and I have a point at 2, 2. Okay. It would also be helpful for me to find D, even though nobody's asking me for that. Halfway between 2 and 12, so that is 10 spaces away. So I'd have to go up 5 and be here at 7. And then you want to make sure that you have 5 here and 5 here. So your A is 5, so it's not those two. And if these are consecutive maximum and minimum points, then this is half of the cycle. That is 2. So the entire period would be 4. I'm looking for B. B is 2 pi divided by 4. And that's where I would get pi halves from. And that would be B. All right, let's put some more points on this curve. We're going to be, if nothing else, I'm going to make y'all experts at this so we're not doing weird things. Graph of H and its dash midline, blah, blah, blah. Coordinates for the points. And we need to write, we're going to find A, B, C, and D, and then write, actually, we just have to find A, B, C, and D. All right, so I'm going to look at my Y values. Let's start. Here are my Y values. The highest ones are at 10. So I know that these are both 10. My smallest Y value is -6. And then I have these here at 2. Okay, so this one I don't have to necessarily back up. I mean, they actually gave me the points. Never mind, they're even labeled. Oh, look at that. It would help if I read my question better. G is at 5, 2, 7, 9, and 11. Okay, beautiful. So now I need A, B, C, and D. So let's do this. A equals, B equals, C equals, D equals. Okie dokie. So here, this midline is at Y equals 2, so D equals 2. Amplitude is here, okay? The distance here, and the distance is not 2. I don't look at those. I look at my y values. That distance is 8, okay? And we'll talk about whether or not it would be a positive or negative 8 here in just a second. For B, I need to figure out the period. So one cycle starts here, ends here, and then, so we can look at it this way. I know this says sine, but that's fine. I can figure it out from cosine. The period would still be the same. 11 minus 3 is 8, so my period is 8. B is going to be 2 pi divided by the period, so I get pi fourths. So B is pi fourths. Now, what I want to use for C is dependent upon whether or not I'm going to use this as a reflection, okay? I think maybe it would be easiest if we didn't use a reflection, if we just thought about it is sine, so it's going to look like this, and just think about starting the cycle here, which means I need to know how far I move it left or right. So I really do need this point. I know the y value there would be 2. And the x value, well, between these two are 4 spaces. So between these two would be 4 spaces. And there's 1, 2 as your ordered pair. Okay, so this right here, if I normally start at 0, I can think about the fact I'm not at 0. I move to the left. I'm sorry, I move to the right, not to the left. Move to the right 1. And so then in my brain, I know that if I move to the right 1, this would be t minus 1. That is how we write that, right? And then I'm going to look at this compared to this. And if I need C, C here would be negative 1. And then A would stay positive because I would be going like so. Okay, so this is the same question that was on the very front. So won't go through all of this again. Let's just go ahead and put our points on here. These were at 60. This was at 24, which made these at 42. 42. And then I had to back it up some, right? So I had this was my 0, 24. This was 3. This was 1.5 or the fraction. Then this was 2.25. This was 4.5. And then 3.75. All right. And then this asks me to find the period, frequency. So I need the period, the frequency, the amplitude. I'm going to put A and P because it is different than just A, and the midline. Okay. Well, midline is right here. That is at y equals 42. Okay, maybe I should have done this instead of equal signs. That's probably what I should have done. Let me fix that. Do that on all those. Although this board doesn't like me to make dots. Midline, amplitude, except when it does for some reason. And this is the period. Period. Okay. So if I can find this, I can find the amplitude. And so the distance from 42 to 60 or from 24 to 42, either way, that's going to be 18. The period, I'm going to start here and end here. Why do I have 4.7 there? That should be 4.5. I don't know what I said when I did it. I feel like maybe I said 4.5. Not sure where the 7 came from. Goodness gracious. 4.5. So going from here to here, or from here to here, doesn't really matter. The period is 3, which makes the frequency 1/3. Then it says to find two intervals for which the graph of h is both decreasing and concave up. Okay, so here we are this is decreasing from here to here, but that's concave down. This is decreasing and concave up. And this would be increasing in concave up. And then this again would be decreasing in concave up. So I need these ordered pairs here so that I can answer my question. Well, if this is 0 and this is 3, this should be 6, and we're still at 24. And if this is at 2.25 and then 3.75, I'm adding 1.5 each time. So that would be at 5.25, 24 would be those ordered pairs. So then my intervals, which are always intervals of the domain, would be from 2.25 to 3, and then 5.25 to, to 6. If I was using fractions, then this would be 9/4 here, and this would be 21/4. It would be the same thing, either way. Okay, so then I need to find A, B, C, and D, and then write the equation C and D. Oh, I'm using equal signs again. Goodness gracious. Well, I guess that's fine. Actually, those are fine there. I don't know what I'm thinking. That's why I got confused on the other one. It doesn't really matter. C equals D equals, because D is just a number here, not an equation. We found our midline. It was at y equals 42, which means D is equal to 42. Amplitude is A, it's our 18. B comes from the period. So since the period is 3, I would do 2 pi divided by the period, and that's 2 pi thirds. And then C would be how much I need to move left or right. So let's see what I'm doing here. This says this is a sine function, okay? So sine would have to start here, like, oh, no, not there. Start here, and well, I'm not calibrated apparently, at 0, 0, or at on the midline, like that's what I'm saying here. So basically here, that would be starting here and getting one cycle of sine like this. So I need this ordered pair as well. I know this y value would be 42. Halfway between 0 and 1.5, if I got out $1.50, that is 75 cents. So I could do 3/4 or 0.75 either way. And since it would have to move right, I know that I would do t minus 0.75. Okay, and since this says plus c, the c value is a negative 0.75. So then when I go to write the equation, it's going to be h of t equals 18 times the sine of b, which is 2 pi thirds, times t plus a negative 0.75, so it's just minus 0.75, still means I move to the right. 2 sets of parentheses there, and then plus 42. And there you have it.